Hi, this is Mr. Cardoso, and in this video we are going to look at angle relationships. Okay, so let's look at the exterior angles of a triangle. So here we have a triangle ABC, and you can see we are extending the line of each side of the triangle, and then we have an angle outside the triangle. These angles are called exterior angles. Okay. If they are inside, over here, for example, they would be interior angles. So these are exterior because they're outside. So we already know that the sum of the angles, the interior angles of a triangle is equal to 180. So let's see what the sum of the exterior angles of a triangle is equal to. So if I take this and I click this button, make the triangle smaller, you can see that the triangle gets smaller and smaller and smaller and smaller and smaller until we get all of the exterior angles joining together like so, and you can see it forms a circle shape. And how many angles are there in a circle? Sorry, how many degrees are there in a full circle? 360 degrees. So if you said that, you'd be right. And you can look here. Let me reset the triangle. If you look here, you can see the measure angles of the exterior angles, and if you sum them up, you get 360 as reported here. Okay, but Mr. Cardoso, what if you change the triangle? What if you move it around? Is this always true for any triangle? Well, let me grab this vertex and change it. Now, you can see, take a look down here, you can see these angles are actually going to be moving and changing, but the sum of those angles is still 360. Oops. What if I move one of these? Okay, you can see that the sum of the exterior angles is still 360, even though the individual exterior angles are changing. The sum remains 360. So the rule here is the sum of the exterior angles of a triangle is 360 degrees always. Let's take a look up here at opposite angles. So when two lines intersect, you can see we have measured here A, B, C to be 61.26 degrees. This angle here is opposite. Now what do you think that angle is going to be equal to? Let's try and see if we can figure it out. I'm going to grab these vertices and I'm going to say measure angle. It comes down here for some reason, but if we drag it up, look at that. We notice that angle ABC is equal to angle DBE. They're both the same. That's because they're opposite angles. So, similarly, angle EBC, which is 118.74, will probably be equal to ABD. Let's check that out. Let's grab these. Let's go up to measure angle, and there you have it. You can see it's equal. But Mr. Cardoso, what if we move the lines? Is this always going to be true? Well, let me grab this and move it along. You can see the angles are changing, but the opposite angles are still the same, no matter how you move those two lines, as long as they intersect. Okay, great. So those are opposite angles are going to be equal. Now, what about supplementary angles? So here we have an example down here at the bottom of supplementary angles, meaning forming a line here. So we have this angle FGI, which is 140 degrees. Let's take a look at this angle. So I'm going to grab these vertices and say measure angle. Drag that down. Okay, so they're not equal. And you can tell probably visually that they're not going to be equal. But maybe they add up to something. Let's check it out. Say we want to calculate this plus this. And look at that. We get 180 degrees. So these is what we call supplementary angles. Supplementary angles always add to 180 degrees. Well, what if we move this guy? Well, notice that the angles change. These individual angles change, but if you still add these up, you can try it on your calculator, you'll still get 180 degrees. So no matter how we move this arm, the supplementary angles still add up to 180 degrees. That's because here we're forming a line which is about half a circle, or a semicircle if you will. Okay. Next, let's look at corresponding angles. Now, this line and this line are parallel. Okay. And these rules only apply if these two lines are parallel. So if I take a transversal, which is a line that just goes through both of them, now we can look at some angle relationships in this figure. So this angle ABC turns out to be 130 degrees. Now because this line cuts this line the same way that it cuts this line, because these two lines are parallel, that means that these two angles will be the same. Okay? No matter how I move this, that line is going to cut both of the parallel lines in the same way since they are parallel. Now, of course, if I take this line and I move it such that it's not parallel to this line anymore, then of course the angles will not be the same. So let me undo that. Okay. Now, what other rules can we find here?
Would Solon come to the office, please? Solon, to the office, please.
Sorry for the announcement there. Now, if we look at this angle, okay, and I'm going to measure that. Well, we see that these two are not the same, but we also notice that they are supplementary, so they should add up to 180. Now, is this going to be the same as any other angle? Let's check this one out. Okay, so we see that those two angles are the same. Because these two angles are the same, it follows that these two will be the same for the same reason, because the traversal cuts those two parallel lines in the same way. And then you can go on, you'll see that here, FD, and then this unlabeled point, if we measure that angle there, that's going to be the same as this because they're opposite. So that's what we learned on the previous slide. This one, again, will be the same as this one. So this one will also be 53.08, and that will follow here. Okay, so you can find lots and lots of different relationships. Okay. You can also look at what we call alternate angles. So if I actually go ahead, let me go ahead and do this one here. I'm going to measure that. We see that this one is 53.08, which is the same as this one because they're opposite angles. So then we can derive another sort of rule. When you see this Z-like pattern, you see that? Follow my cursor here. See that Z here? And these two lines are parallel. That means these corner angles will be the same. Okay, and so you can see another Z-like pattern. It's backward Z here. We have this angle. So from this, just from this alone, we can figure that this is going to be 126.92. Okay, so if I measure this angle here, measure angle, that one will be the same as this one because of that backward Z pattern there. Okay, and of course it's the same as that one because they're opposite angles. So again, you can take this line and you can drag it, and all of these relationships will stay intact. The only thing that will kill all of these relationships is if these two lines are no longer parallel. So if I do that, then of course all is not good in the world anymore with these relationships. Okay, let's move on to complementary angles. If this is a 90 degrees, then and we drag this arm around, what do you think angle A and B are going to add up to? If you said 90, you'd be correct. So let me grab this, add it to this, and you can see that B plus A is equal to 90, no matter how we move that. Okay. Moving on to exterior angles. This corresponds to a triangle again. So let's go back to a triangle. If we extend any of the sides, in this case we extended this side here, the exterior angle there will be equal to the sum of the two opposite interior angles. Okay, so how can we prove this? Let's take this and let's calculate it. Let's take this plus this and click OK. And notice that B plus C equals 133.62. Okay, what if you change the triangle? Relationship stays intact. Okay, so these are the two opposite interior angles are equal to
Would
the
someone come to the office,
opposite
please?
exterior angle. Okay, great. So that finishes this little video on simple angle relationships. This is Mr. Cardoso. I'll see you in the next video.